you don't have page 11 printed, if I can have you on your sheet of graph paper. This is technically, you know, up until this point, those topics that were covered are things that you guys should have seen in middle school. True or false, you guys? You all saw up to rotations in middle school. And that was mainly for most of you guys review. Even if it was something that, you know, we could use more practice on, it's something that you guys agree you saw in. Okay. Okay, so glide reflection is actually part of geometry as it is covered in at the high school level. So some of you guys might have seen it, some of you don't, but it's not very difficult to do. It has two words to it. So the glide part of it is going to be the first component of it, and the reflection part of it is going to be the second. When you guys glide, which transformation do you guys feel like would glide be most similar to? A reflection, a rotation, or a translation? What do you guys think glide sounds like?
Translation.
A translation. Okay, so a glide reflection is a translation first. Okay, so a translation first. So think of gliding left and right, gliding up and down as you're dancing. And then two, you would do the reflection. So for example, on the one that I'd like you guys to write down is the coordinate point A. So go ahead and write this coordinate point down if you don't have it currently on your printed out. A is 2, -1, B is 1, 1, C is 3, 3. And what they'd like us to do here is the glide reflection in example 1 moves all the points 3 to the right, and then reflects all the points in the x-axis or across the x-axis. Okay, so the coordinate point is written out for us. Okay, so what you'll see is that there's now two transformation that occurs. So under this first column, this is going to be the translation. And then this is going to be, you'll notice that now it refers to it as A double prime. And that is after you guys do the translation, we're going to do the reflection across the x-axis. So this is after the reflection. So for now, let's plot A. So A is 2, -1. B is 1, 1. And C is 3, 3. And so if they want me to move all the points 3 to the right, is that +3 on the x or -3 on the x? Okay, +3. So we're going to go ahead and add 3 on all of our coordinate points here where there is an x. Okay, so if I add 3, I get 4 here. If I add 3, I get 6 here. And then all the y coordinates stay the same. And I'm basing this off of the description that they have above there. Add 3, 3 to the right. So physically, I'm going to go ahead and move these 3 points 3 to the right, and then label them A prime, B prime, and C prime. And then the last transformation, I'm going to change the colors. The colors make it look just a little bit more friendly on the eyes. But on here, now they want us to do, so again, glide reflection, always translation first. Then the reflection is across the x-axis. If I envision my x-axis as the folding, where the fold occurs, physically, this A prime now becomes, now goes up here. So we can see that all of our y values change to be the opposite in sign. So we can go back to this column here and change all of our y coordinates to be the opposite of what it currently is. So we keep the x value the same, +1, 4, -1, the opposite, and 6, -3. And those will be our double primes. And let me just make sure that I did the, it should be prime. All right, go ahead and plot those points. But that's pretty much it, you guys. That's what we would call a glide reflection. So this point up here is now A double prime, B double prime, and C 3 units down. And this was asking us to, it did say triangle. This is the symbol for triangle ABC. So I'm going to graph the A double prime, our final product. A double prime, B double prime, and C double prime. Okay, so if you did not have, again, printed for the second one, we're going to do together as well. I'm going to quietly allow you guys to do the indicated glide. So first, they're using arrow notation, and then they ask you guys to do that reflection. So go ahead and start off by plotting the points for me for the second example. Just so you guys see the vector notation for that translation, since x is being subtracted by 2, but y has nothing being done to it, I put 0 as the quantity that we're adding to y, which is nothing. So you're not adjusting y in any way. So you can either use vector or just kind of want to make sure you guys understand the vector notation so that when it does show up, it makes sense to you. Okay, go ahead and double check your work. My final one is the purple one here. And we're gonna leave it at that. I'm gonna have you guys, your homework tonight is slide translations. Does anyone have any questions on